Hello guys, I am Nidhi Bagalwadi, Sankalp Learning Solutions, your science teacher. So in the last class, we learned regarding the refraction, how the refraction takes place through the glass slab. So in today's class, we are going to discuss in detail regarding the refractive index, right? In the last class, we also studied regarding the laws of refraction, where the first laws of refraction says the incident ray, the refracted ray and the normal at the interface of two mediums will be in the same plane. And the second law tells us that the sine of the angle of incidence to the sine of angle of refraction gives a certain value or a constant which is considered as a refractive index of that medium. Okay, so the refractive index of that medium is not only concerned to that ratio only, it is much more. So let us learn in detail regarding the refractive index, what all factors influence it and how we will use it in our daily life, right? Yes, the refractive index of a medium, as you can see in the diagram here, I consider two mediums, air and a glass. Air I considered as a medium 1, glass I considered as a medium 2. Then as I said, the refraction is nothing but the bending phenomenon of the light. Why the light will bend? Because due to the change in speed of the light in different mediums. The speed of light will not be the same in all the mediums. So here when we consider the mediums, we should keep it in mind that those are nothing but the transparent mediums only. So in all the transparent mediums, the speed of light differs. So due to the difference, due to the change in speed of light, the refraction phenomenon occurs. So here the refractive index can also be determined by using the speed of light. So the speed of light in case of air is 3 into 10 raised to 8 meter per second. When we come to the water, it is 2.25. When we come to the glass, it is 2 into 10 raised to 8 meter per second. So as you can see, from the air to the glass, the speed of light is decreasing. The speed of light is decreasing. So the refractive index can be given by the speed of light in air divided by the speed of light in the medium. So let us see the refractive index here. The refractive index of medium 2 with respect to medium 1. So we should write medium 2 with respect to medium 1. This is how we have to represent. This is small n. Medium 2 with respect to medium 1 will be given by speed of light in medium 1. It is represented by lowercase v, that is small letter v1 divided by speed of light in medium 2, that is lowercase or small letter v2. This is a refractive index of this refraction. Now, if I want to know the refractive index of a first medium with respect to second medium, because two medias are different, so I want to know the refractive index of first medium. So I will write n to the subscript of 1, 2. First medium with respect to second medium is given by speed of light in second medium, that is lowercase v2 divided by speed of light in first medium, that is lowercase. Lowercase means small letter v1, that is speed of light in first medium. So this is how the refractive index can be determined. So let us consider v1, that is air. We know the speed of light in air will be constant. In air or a vacuum will be constant, and it is given by a standard value 3 into 10 raised to 8 meter per second. So that is why if we want to consider, if you want to find any refractive index of the medium with respect to the air or a vacuum, we can write it as refractive index of a medium is equal to speed of light in air divided by speed of light in the medium. So speed of light in air is designated or is represented by lowercase c, constant. It will be constant, divided by speed of light in the medium. Whichever medium you take, you might take glass, you might take any benzene liquid, you might take the crown glass, quartz, ice. So these all are the other mediums with respect to the air. So the refractive index of the medium with respect to air will be given by this equation. Nm is equal to C by V. Nm is equal to C by V. So based on this refractive index, one of the term is defined, that is a optical density. Optical density means it is not a physical density. For example, when we put water and oil in one glass, the oil will float upwards, water will be down. Why? It is due to the density of the oil. So it is different and optical density is different. So the optical density here, it means that how the denser or rarer medium it is. Whatever you took the transparent medium, how denser it is, how rarer it is. So what are these two terms, rarer and denser? Let me explain you. Here, for that, let us consider again. Let me consider a glass slab. Okay. Okay. Then after that, let me name it as A, B, C, D. Let us consider a ray of light PQ is incident on AB. Then it will get refracted again like this. And we will draw the normal. Here also we will draw the normal. Okay, it is just a rough diagram. Now, here I will write the angle of incidence, angle of refraction, angle of incidence I2, angle of refraction R2, R1, I1. Okay, I1, R1. Now, see here, when you see the R1, this angle, and when you see the R2, this angle, R1 and R2. So, the angle of refraction, here it is towards the normal. It is reaching to the normal. Here the light is in air, here the light is in glass, here again the light is emerging to the air. So when a light ray travels from air to the glass, the light ray, the refracted ray is moving towards the normal. So here when you see the light ray has a refractive index 1 and glass has a refractive index 1.53. And speed of light is more in air, speed of light in less in glass. So when a speed of light decreases from air to the glass, it will bend towards the normal. It will bend towards the normal. So here the medium which has a less refractive index, or we can say the medium in which the speed of light is more, then that medium is considered as a rarer medium. Okay, here when a light ray travels from rarer medium to denser, what do you mean by denser? Where the refractive index will be more or speed of light will be less. So that is called as denser medium. Okay, so when light ray travels from rarer medium to denser medium, the refracted ray move towards normal. In the same way, when you see here the light ray is emerging or passing from denser medium to again the rarer medium, that is air. Okay, so here when it travels from denser medium to rarer medium, the refracted ray moves away from the normal. You can see the R2 is greater. R2 is greater than R1 because angle of refraction, the light ray move away from the normal when it travels from denser to rarer medium. Why it moves away? Because the speed of light increases. 2 into 10 raised to 8 meter per second becomes suddenly 3 into 10 raised to 8 meter per second. That's why it moves away from the normal. So this is regarding the rarer medium and the denser medium. So you can define those mediums as where the speed of light is more, then that medium is called as rarer. Where the speed of light is less, that medium is called as denser medium. And these all are the refractive indexes of those. The refractive index of air goes It is 1. The refractive index of water 1.33 and refractive index of glass is 1.53. Okay, so this is regarding the refractive index of the medium. So what all we learnt? We learnt regarding refractive index, we learnt regarding optical density, then we discussed regarding the rarer and denser medium. In the upcoming sessions, we will learn more about the refraction phenomenon as well as the reflection phenomenon. Until that, learn science, observe science. Have a nice day.